So dear students, class 9th motion chapter, in the next segment we are discussing some of the velocity time graph. If you observe the first graph, in this graph I hope it is visible to all of you. This is the origin and something is below the origin, it means negative side. And in the lower one graph it is visible to you, this is the origin and velocity is above the origin, it is positive. Of course I have mentioned here the north and south also. Same thing here, north and south also. But you can interpret it plus y-axis or minus y-axis, it doesn't matter. Now if you observe such type of the graph, the first impression which you get, I hope it is visible to all of you, it is the horizontal line on the velocity time graph. When there is a horizontal line on the velocity time graph, we will say the object is moving with constant velocity. So for both the graph, we will say object is moving with constant velocity. And I think all of you are aware, if velocity is constant, acceleration will be 0. But for the above this graph, I can say the object is moving with a constant velocity toward the south direction. And for lower one, I can say, for upper one, you can say object is moving with a constant velocity toward the north direction. And for lower one, we can say object is moving with a constant velocity toward the south direction. And as I told you, we can interpret in the plus y-axis or minus y-axis, it doesn't matter. If you observe the next graph, I hope it is visible to all of you. If I say this is the origin, then velocity for the time is changing. I said this time is 1 second, 2 second, 3 second, 4 second, 5 second and so on. But it is visible to all of us that velocity is 0. It means we can say object is at rest and object is not moving. So if we observe such type of the graph in future, what we will say, object is not moving or object is at rest. So this is the interpretation of this graph. There are two more graphs are given here. You have to analyze the velocity time graph. I am again telling you, please pause the video and please interpret yourself, then you listen me. It will clear your concept more. So if I observe the first graph, I am observing this graph first. This one. I am putting the highlight here. I am observing this graph. I hope it is visible to all of you. In this graph, this is a graph between velocity and time, and everywhere if I observe the slope is constant. Because this is the theta is constant everywhere. So we will say theta is constant everywhere. Theta is constant, tan theta is constant. What is the tan theta? Tan theta is a slope. And this is a slope between velocity and time graph. So when the slope between velocity and time graph is constant, we will definitely say acceleration is constant. One more thing here. Here theta is acute. Tan theta is positive. So I hope all of you can easily say me acceleration is positive. Now I am coming to this graph. Again in this graph it is visible to all of you. If I plot the slope anywhere, it is visible to all of you that theta is same everywhere. Theta is same, tan theta is same. And what is the tan theta? Tan theta is the slope of the velocity time graph. And again I will say acceleration is constant and that is a positive acceleration. So I have explained both the graph. Now we will discuss the next one. So we observe the next graph between the velocity and time. When you observe the graph, I think again it is visible to all of you. This is a straight line graph. And if you observe the slope anywhere, suppose I observe the slope here on this graph. This is the slope, my theta. Theta is constant everywhere. It is not changing. It means tan theta, that is also constant. And what is the tan theta? Tan theta is the slope of the velocity time graph. And we all intelligent, it is known as acceleration. It means here we will say acceleration is negative. Velocity of course positive. We come to the right hand graph. Again on this graph you observe at each and every point theta is same. But theta is obtuse. Same thing, theta is obtuse here also and theta is obtuse here also. But theta is constant. So we will say tan theta is constant. And tan theta is the slope of the velocity time graph which gives the acceleration, and it is the negative acceleration because theta is obtuse on both the graph. So tan theta is negative, and when tan theta is negative, we will say slope is negative, velocity time graph slope gives the acceleration is negative. Now we observe the graph. Here we have to determine the displacement of the body during the first 4 seconds. This is the first 4 seconds. When you observe the graph, it is visible to all of us that the velocity direction is not changing. It means for this time interval, if we are calculating the distance and we are calculating the displacement, both the answer will be same. And we all know distance or displacement is the velocity, is the area under the velocity time graph. So from 0 to 4 seconds, I shade the area. This is the area. We have to calculate the area of this yellow shaded part. And if I say this length is 4 and this is 30 minus 0 is 30. So area of the rectangle, all of you know, that is the length into width. So displacement is given by area under the velocity time graph. And here it is a rectangle, and rectangle area is length into width. I can say 40 into 30, and when we calculate it, it is 120 meter. So this is the answer of this problem. Next, in this situation, there is again a graph is given between velocity and time, and we have to plot and we have to calculate the distance to the object in 10 seconds. As I told you in the last slide, distance or displacement can be determined with the area under the velocity time graph. Here for 0 to 10 seconds we have to calculate. So firstly, let us shade the area which we have to determine. This is the area which we have to determine. And I hope it is visible to all of you. It is right angle triangle. So we write here, displacement is given by area below velocity time graph, and it is a right angle triangle. Right angle triangle means half base into height. Half base, I hope it is visible to all of you. This is 0, this is 10, 10 minus 0 is 10. Height, this is 20, this is 0, 20 minus 0 is 20. When we calculate it, it is 100 meter. So answer of this problem is 100 meter. It is a distance traveled by the object in 10 seconds. Now, it's very simple thing for all of you. If anyone you ask, what is the slope of velocity time graph? You can easily say it is the acceleration. If anybody asks you, what is the slope of displacement time graph? You will say it is velocity. What is slope of speed time graph? It is speed. Oh, sorry. Let me correct it. Just a second. What is the slope of distance time graph? You will say it is speed. And what is area below velocity time graph? It is displacement. And if direction is not changing, displacement distance both are same. So these are the some conceptual things which you are supposed to know at this level. Again, we are going to another problem here. And student, as I am telling you, you just pause the video, you solve yourself, and then check from my solution. Again, in this situation, we have to ask which of these lines has a greater acceleration. There are two lines A and line B, and we have to determine which line is having greater acceleration. This is the velocity time graph. First of all, you observe this is the velocity time graph. And it's a straight line. Straight line means all of you say acceleration is constant. Because anywhere you observe the slope, slope is constant. And slope determines the acceleration. If I say here the slope, I say this angle is theta 1. Everywhere the angle is same. Theta 1, theta 1, theta 1. Means for graph A, angle is theta 1. And for graph B, I measure the angle with the x-axis. I say it is theta 2. Graph is theta 2. So let me clear here again. If you observe the velocity time graph, we observe the slope, and for the slope we want angle theta. So here I say this angle is theta 1, and here I say this angle is theta 2. I hope it is visible to all of you. Theta 2 is greater than theta 1. It means tan theta 2 is greater than tan theta 1 because it is acute situation. So what we can say? Slope of graph B is more than graph A. So acceleration of graph B is more than graph A. I hope it is clear to all of you. Again I am explaining you. We observe the slope, we observe the theta. Theta for the B is greater than theta for the A. It means slope for the B is more than slope for the A, and slope of the velocity time graph gives the acceleration. So acceleration of the B is more than acceleration of A. Okay, one more problem is there. Again we have given velocity time graph and it is asked to determine which of these lines has a greater acceleration. Children, if you minutely observe this graph, I hope it is visible to all of you. If you observe the graph A or graph B, everywhere theta is 0. When theta is 0, slope is 0, acceleration is 0. It means acceleration of A is 0 and acceleration of B is also 0 because there is no theta, there is no slope. Again I am telling you, if we have the slope between velocity time graph, with the help of the slope we are able to calculate the acceleration, but here slope is 0 because this is the horizontal line and this is the line of A. Angle between the horizontal line and line A is 0. Angle between horizontal line and line B is 0. So slope is 0. So both A and B has 0 acceleration. Now children, I hope it's quite simple situation for all of you. Which of these lines has a greater velocity? If you observe the velocity time graph, it is visible to all of you. Either it is object A, object B, both of them are moving with constant velocity. And it is clearly visible to us, object A has a more velocity compared to object B. So we will say object A has more velocity compared to object B. And what is the velocity of object A? If we give some idea, if I say it is intersecting exactly the center, this is 120, this is 120, this is 140, we will say it is 130. So velocity of A is given by 130 meter per second. Now, again I am giving you one problem. Now I think you people are very much intelligent at this stage because we have discussed a lot of things about the slope. Which of these lines has a greater deceleration? Deceleration means negative acceleration for class 9th level. I will say it is a velocity time graph and 100% I am sure all of you will say this is a straight line graph and acceleration or deceleration is constant. I observe the slope anywhere, theta, theta, theta. I hope it is visible to all of you. For this graph or for this graph, everywhere theta is same and theta is obtuse also. When the theta is same and theta is obtuse, we will say acceleration is negative. So I hope it is quite visible to all of you. Which has the greater acceleration, greater deceleration? Object A. Its slope is more. So answer for this line is object A. Now again one problem is there. We have to determine the acceleration between 1 and 4 seconds and velocity time graph given. Students, I hope you will easily say me acceleration is slope of velocity time graph. You will say. Now, if you observe this graph, everywhere you see theta, theta is same, it is not changing, but theta is obtuse, of course, because theta is always measured from the x-axis, theta is obtuse. When theta is obtuse, we all are intelligent, acceleration will be negative here. So what is acceleration in this situation? Slope. Slope means this is the perpendicular and this is base. This is 10, this is 0, 10 minus 0 is 10. This is 5, this is 0, 5 minus 0 is 5. But as theta is obtuse, I have to put my negative sign here. So what is the answer? Acceleration is given by minus 2 meter per second square. If somebody asks you what is the retardation? Retardation is the negative of the acceleration, you will say it is 2 meter per second square. So in the same problem we have calculated the acceleration, same problem we have calculated the retardation. Okay. Again there is a graph between velocity and time. The red line is given to you. And you have to comment for the acceleration and for the velocity for the region A, region B, region C and region D. Children, firstly we will discuss the region A. Again you will say this is the velocity time graph, and for the region A, graph is a straight line. And when the graph is straight line, we all are intelligent. Theta is obtuse here, theta is constant here, tan theta is negative. It means graph A represents deceleration or decelerating graph. What is for the graph B? If you observe the graph B, I hope all of you will say constant velocity, that is the 0 meter per second. It means we will say, of course velocity is constant, but velocity is 0 meter per second. When the velocity, it is 0 meter per second, not per second square. Let me erase it. Okay, velocity is 0 meter per second, and when the velocity is 0 meter per second, you will say object is at rest, and when the velocity is constant, acceleration is 0. Now you come to the graph C. Again it is a straight line. We observe the theta. Theta everywhere is acute and constant. We will say it is acceleration. Again we come to the graph D. This graph you will say object is moving with a constant velocity. And what is the velocity for this region? 15 meter per second. And when the velocity is constant, we all know acceleration is 0. But children, what is the difference in this graph and this graph, B and D? In the B, object was at rest, but here object is not at rest. Object is moving. So this is the interpretation of such graph. Okay. Here we are giving you velocity time graph of a body moving in a straight line. I hope it is clearly visible to all of you. It is written here. It is moving in a straight line. It's shown in the figure. Find the distance or displacement of the body in 6 seconds. Children, when you observe the velocity time graph and it is asked to calculate the distance or displacement, quite obvious you are supposed to calculate the area below the graph. So firstly let me measure the area below the graph. So let us highlight the part of the area which we have to determine. Like I say, we have to determine this area, we have to determine this area, and we have to determine this area, because this is the area below the graph. Now I mark some point. I say this is the O, this is A, this is B, this is C, this is D, this is E, this is F, this is G, this is H, and this is I. Area of rectangle OABC, length into width. This is 2, this is 4 minus 0 is 4, 4 into 2 is 8 meter. Area, again there is a rectangle CDEF. This is 4, this is 2, 4 minus 2 is 2, this is minus 2, this is 0, minus 2, 0, we take only magnitude just now only, 2 minus 0 is 2, so 2 2 is 4 meter. Again there is one more rectangle is there here, area of rectangle FGHI. 6 minus 4 is 2, 2 minus 0 is 2, 2 2 is 4 meter. Now if we have to calculate the displacement first, suppose we are calculating the displacement. This is the positive area, this is positive area, this is negative area. So we will say OABC means 8, then minus 4, then plus 4, we are getting 8 meter. This is the displacement. Now we measure the distance. As we have discussed, distance can never be negative. It is always positive. And we have discussed displacement may be positive, may be negative, may be 0. So when I calculate the distance, 8 plus 4 plus 4, it is 16 meter. So children, this is the answer for the displacement. And displacement, why I have taken the negative sign? Because we know displacement can be negative. Of course the graph is going towards the negative side. Distance always positive, so it is 16 meter. Now if you are able to calculate the distance and displacement from the graph, you are easily able to calculate the average velocity and average speed from the graph. Because average velocity is the displacement upon time, time is given to you 6 seconds. And average speed is distance upon time, time is also given to you. So that we will discuss in the next segment. So that's for you regarding the velocity time graph. In the coming video we will discuss more topic for the class 9th motion. Thank you.